The following presentation features the use of a Lincoln Electric combination wire feed welder. For best results, always use Lincoln wire and replacement parts. This is your best assurance for premium feedability and trouble-free operation. Lincoln Electric, world leader in the manufacture of arc welding products, welcomes you to a new era in workshop welding. Your new compact lightweight welder is specially designed and engineered for easy operating, safety, and long-term service. Lincoln has set the standard in industrial welding for over a century. Your new equipment was manufactured with the same care and attention that goes into all Lincoln products, so you can enjoy many years of dependable, trouble-free service. Your new welder is an easily portable power source and wire feeder combination. It's been designed for workshop, hobby, and light maintenance uses, even light-duty general-purpose welding with self-shielded flux cord inner shield wire or solid wire with shielding gas. These machines can be used to weld low-carbon steels and aluminum with the FCAW and GMAW processes. Please note, some 125-amp machines are FCAW only and cannot weld aluminum. For lists of wire types, sizes, and recommended shielding gases, look at the inside of the door panel on your Lincoln welder. In simple terms, welding is melting two pieces of metal together using localized high-intensity heat. In arc welding, the heat is generated by electric current that flows from the machine through the cable and gun assembly to the wire and across the arc. On the work side of the arc, current flows through the base metal to the work clamp and back to the machine. During the welding process, the arc forms a pool or puddle. To assure a solid weld, this puddle must be filled with additional weld metal from the weld wire. You're also probably aware that the weld must be protected from the surrounding air to prevent weld defects. The easiest way to do this is by welding with self-shielded flux cord wire, or inner shield. The core materials burn in the arc to create a protective slag that keeps air away from the molten metal. You can also keep air away from the welding area by introducing a shielding gas. This method uses a different wire and is known as gas metal arc welding. You'll find that most metal items around the home or workshop are made of low-carbon steels, also called mild steel. They are easily welded. Your welder can handle most of these light-gauge, low-carbon steel materials, and with practice, they are easily welded. Some steel contains higher carbon levels or other alloys, making them more difficult to weld. These samples or exotic metals are not recommended for welding with your wire feed welder. Basically, if a magnet sticks to the metal and you can cut the metal easily with a file, chances are very good that you will be able to weld the material successfully with your new machine. The Lincoln publication, New Lessons in Arc Welding, provides in-depth detail for identifying various types of steel and other metals and the proper procedures for welding them. These wire feed welders are protected by a thermostat and a circuit breaker. The machines shut down if their amperage ratings are exceeded or if the machines start to overheat. There's no question that welding with any machine can be dangerous if strict safety procedures are not followed. If you adhere to the precautions exactly every time, you will minimize or eliminate the hazards from electric shock, arc rays, fumes and gases, and stray welding sparks. You will avoid many work hazards by keeping your workplace clean and free of fuels, chemicals, paints, solvents, and other materials that can ignite if struck by a hot welding spark. Of course, a fire extinguisher should be handy. Your workspace should be out of the way so that others don't inadvertently look at the arc, get struck by a spark, or distract you from what you are doing. Suitable dress includes dry clothing made from flame-resistant materials. Treated cotton or wool are good choices. Long-sleeve shirts and long pants without cuffs to catch hot weld spatter shield your body against sparks and harmful arc rays. Dry, hole-free leather work gloves help protect hands from the danger of burns from hot metal and electric shock. High-topped leather footwear is best. Long hair should be tied back or tucked under a hat. Some tools needed for safe operation include welding helmets or face shields with arc welding filter lenses for you and any assistants, pliers for picking up hot metal, a chipping hammer, safety glasses, a wire cutter, a wire brush, and clamps. Your body should not come in contact with the welding circuit. If any part of your body could come in contact with the metal being welded, insulate yourself from the workpiece on the welding circuit by using a non-conductive, non-flammable material, such as a rubber mat. Remember, the electrodes and work circuits are electrically hot whenever the welder is on and the gun trigger is pressed. Before you start welding, make sure the work surface is clean and free of contaminants that may ignite or generate toxic fumes. Galvanized or painted steels are typical sources. Never weld on containers that have held combustibles such as gas cans, paint cans, or even hydraulic hoses. They could explode. If you're not sure, don't weld on it. And always disconnect electrical devices before welding on them. Try to work in a comfortable position. If you must work in an awkward position, take additional care to avoid injury. Fumes and gases are a normal byproduct of the welding process. Use enough ventilation to keep fumes and gases from your breathing zone and general area. When welding indoors, it may be necessary to use an exhaust system. Always turn off and unplug the unit when you're not welding or servicing the machine. Also remember to turn off your shielding gas when you are done welding. And finally, improperly maintained equipment always poses the potential for problems. Be sure that all connections are tight, that there are no breaks in the cable or gun insulation, and make sure that all components are in proper working order. Never weld with equipment that has damaged or missing insulation. Your new wire feed welder is a reliable, safe tool. You should always adhere to the safety guidelines and use common sense. But remember, safety depends on you. As shipped from the factory, your new welder has everything you need to start inner shield or self-shielded flux cord welding. To be a real pro, you'll need a welding helmet, leather gloves, safety glasses, a chipping hammer, a wire brush, clamp, pliers, and a fire extinguisher. If you don't already have these items, we recommend that you purchase them before you start welding. They'll come in handy and make your job easier and safer. Your wire feed welder must be plugged into the proper receptacle and plugged into system ground approved by the National Electric Code and local codes. But be sure to select a circuit that has few or no other appliances drawing power. This will eliminate tripping the circuit breakers or blowing a fuse. Extension cords, if required, must be rated for the application. Use grounded outlets only. Do not use an adapter. Have a qualified electrician install a grounded outlet for you. The welder should be installed in a dry area, and there should be an open area around the louvers, front and back. Be sure you can open the access door on the side of the unit. After the machine has been set up and the gun and work cables have been installed according to the instructions in your welding guide, you can then prepare the unit for welding. Locate the sample of .035 NR211MP flux cord wire and place onto the wire spool spindle. Orient the spool so that the wire feeds off the top of the spool. Secure the spool by tightening the wing nut against the spacer that holds the wire spool on the spindle. Do not over-tighten the spool. Open the pivot arm assembly by rotating the tension arm assembly down and lift the pivot arm assembly up. Remove the drive roll by unscrewing the black knob that holds the drive on. Install the dual groove drive roll with the .035 mark facing outward, which will allow feeding of the .035 NR211MP flux cord wire. Carefully undo the wire at the point where the wire anchors to the spool. Cut approximately 2 inches off the end of the wire. Do not let the end of the wire go to prevent the wire from unspooling. Feed the wire through the incoming guide, over the drive roll groove, through the outgoing guide and wire drive outlet on the gun side. Close the pivot arm assembly and secure by rotating the tension arm assembly back to the up position. Rotate the tension arm knob until the numerical dial indicates about 3. If the wire slips on the drive roll, increase the pressure until slipping stops. If the wire becomes flattened excessively, loosen the pressure adjustment to reduce the distortion. Remove the nozzle from the gun and contact tip and straighten the gun out flat. Turn the machine power to on and depress the gun trigger. Turn up the wire speed control to feed the wire through the gun liner until the wire comes out of the threaded end of the gun several inches. Hold the gun away from yourself and others while feeding the wire. When the trigger is released, the spool of wire should not unwind. Adjust the wire spool brake accordingly. Turn the machine off and install the .035 contact tip. Install the black welding nozzle to the gun. Trim the wire stick out to 1/2 inch from the contact tip. Also keep in mind that the 1/2 inch stick out is important while welding. The setup for inner shield welding is now complete. No one can be an accomplished welder by watching this DVD or reading books about welding. As with so many things, the key to success is practice. But this brief overview will get you started and help you develop your skills. More details are in your welder's guide and in new lessons in arc welding. There are 5 basic welding joints or ways to join metal together: butt welds, fillet welds, lap welds, edge welds, and corner welds. Of these, the butt and fillet are most common. But regardless of the process, gauge, steel, or weld joint, successful welding starts with proper surface preparation. The area to be welded should be free of rust, paint, oil, or other contaminants. Sand, grind, or wire brush the work area. Remove any traces of solvent you may have used to clean off oil. Now let's take a look at a specific example. Here we are using 2 pieces of 10 gauge material. Set the voltage and wire speed according to the chart on the inside of the wire feed section door. If you're unsure of the metal thickness, check it against the gauge chart on the same door. Once you have adjusted the settings, position your pieces and, if possible, clamp them in place. Attach the work clamp as close to the joint as you can. Be sure it makes good electrical contact. This will reduce the resistance in the welding circuit and let your welder perform efficiently. Use care in preventing the electrical circuit from going through hinges, chain hoists, or electrical components. It can severely damage them. If you are right-handed, hold the gun in your right hand. And remember to always make sure you have the proper face and eye protection before you begin. Weld left to right, tilting the gun in the direction of travel. This enables you to clearly see what you are doing. Left-handers simply need to do the opposite. Now turn on the machine. Position the gun at the corner of the joint and squeeze the trigger to tack the material in position. Be sure to keep the trigger depressed while welding. To minimize distortion, place the tack welds 3 inches apart along the joint being welded. Here's what a good tack weld looks like. Now you can begin welding. Again, to minimize distortion, weld with a backstepping technique. This technique involves evenly distributing the heat by welding in sections. The important thing to watch while welding is not the arc, but the molten puddle behind it. And remember, you should always maintain the proper electrode 1/2 inch stick out beyond the contact tip while inner shield welding. When finished, let the workpiece cool. Remove the slag with your hammer and examine the weld. This is an example of a properly completed weld. And this is an example of an improperly made weld. It was done without proper tacking and no backstepping. The most common mistake of beginning wire welders is not fully completing the electrical circuit with a sound metal-to-metal connection. Without a completed circuit, there will be no arc. Beginners also tend to weld too fast. The result is a thin, uneven bead and poor penetration. Poor penetration creates a weak weld, prone to failure. With proper penetration, the weld will actually be stronger than the base metal. On thicker plate, you may have to slow down even further to get proper penetration. Keep in mind, though, that there are cases when welding too slow can cause other problems. When welding on thinner plate, you may have to increase welding speed to prevent the arc from burning through the base metal. In your welder's guide is a practice exercise that will help you hone your welding skills. There are tips on running beads and gaining proper penetration for all the various types of welding joints. In addition, your welder's guide contains a section on troubleshooting welds with photographs to help you identify and solve problems you might encounter. If applicable, your new wire feed welder can also be used for MIG welding. Enjoy the ability to weld with either the inner shield or MIG process to better fit all your welding needs. Some 125 amp machines are not MIG capable. You will need to obtain a cylinder of CO2 or CO2 argon gas blend to serve as shielding gas, along with a list of safe handling procedures from your local welding supplier. There are some very important differences to be aware of when changing from flux cord to MIG welding. Reversing the machine's polarity is one. Locate the sample spool of .025 L56 solid MIG wire and place onto wire spool spindle. Orient the spool so that the wire feeds off the top of the spool. Secure the spool by tightening the wing nut against the spacer that holds the wire spool on the spindle. Do not over-tighten the spool. Open the pivot arm assembly by rotating the tension arm assembly down and lift the pivot arm assembly up. Remove the drive roll by unscrewing the black knob that holds the drive roll on. Install the dual groove drive roll with the .025 mark facing outward, which will allow the feeding of .025 L56 solid MIG wire. Carefully undo the wire at the point where the wire anchors to the spool. Cut approximately 2 inches off the end of the wire. Do not let the end of the wire go to prevent the wire from unspooling. Feed the wire through the incoming guide, over the drive roll groove, through the outgoing guide and wire drive outlet on the gun side. Close the pivot arm assembly and secure by rotating the tension arm assembly back to the up position. Rotate the tension arm knob until the numerical dial indicates about 3. If the wire slips on the drive roll, increase the pressure until the slipping stops. If the wire becomes flattened excessively, loosen the pressure adjustment to reduce the distortion. Remove the nozzle from the gun and contact tip and straighten the gun out flat. Turn the machine power to on and depress the gun trigger. Turn up the wire speed control to feed the wire through the gun liner until the wire comes out of the threaded end of the gun several inches. Hold the gun away from yourself and others while feeding the wire. When the trigger is released, the spool of wire should not unwind. Adjust the wire spool brake accordingly. Turn the machine off and install the .025 contact tip. Install the copper or brass welding nozzle to the gun. Trim the wire stick out to 3/8 of an inch from the contact tip. Also keep in mind that the 3/8 inch stick out is important while welding. The setup for MIG GMAW welding is now complete. The actual welding process is similar to inner shield welding. Here's how a MIG weld should look. Notice that there is no slag to remove. Routine care, maintenance, and storage of your welder is easy, and when properly cared for, it will provide years of trouble-free performance. Take care not to kink or pull the cable around corners. Do not allow anything to roll over the cables. When storing the unit, carefully coil the cables to get them out of the way. You may also want to cover the unit to protect it from dust. Of course, never leave it where children can get to it or in very damp locations. You should occasionally clean out the inside of the welder to remove excessive dirt and dust buildup on internal parts. When necessary, clean dirt from the gearbox and wire feed section. Inspect the incoming guide tube and clean the inside of it if needed. The wire feed motor, fan motor, gearbox, and wire reel spindle have lifetime lubrication and require no maintenance. Keep in mind that the contact tip does wear out and occasionally needs replacing, typically when the hole in the contact tip becomes elongated or if the tip contacts the molten puddle. Because of the gun assembly design, the changeover is quick and easy. Replacement tips, wire, and other welding supplies are available at your local welding supply distributor. The Welder's Guide has a complete list of part numbers. And of course, should your welder require professional service, your Lincoln Field Service Shop is only a phone call away. Let's quickly review some key points. Your new welder can handle most light gauge mild steel. If the metal passes the magnet and file test, chances are you'll be able to weld the material. Remember to consult the chart on the inside of the wire feed section door for proper voltage and wire feed settings based on metal thickness. Be sure the work clamp makes good contact in order to establish the welding circuit. After establishing an arc, watch the puddle to determine the appropriate travel speed. And most important, practice proper safety precautions for yourself and others in the area. And remember to read through the Welder's Guide and Owner's Manual that came with your new welder. With practice and strict adherence to safety procedures, you will soon become an accomplished welder. Good luck and happy welding!